These notes are all about how to draw free body force diagrams. So your learning target is, I can draw a free body force diagram. So just as a review, what are the four types of forces? We have applied force, which is the push or pull, friction force, which is opposite of applied, gravity force, which is your pull towards Earth, or normal force, which is opposite of gravity. What are free body force diagrams? A free body force diagram shows the direction and the magnitude of the forces on an object. The forces are represented in arrows. So if forces are balanced, all of the arrows are the same size. If forces are unbalanced, at least one arrow is different in size. Shorter arrows mean that you have a smaller force. Longer arrows mean that you have a greater force. And the long arrow shows the direction of the movement. So if we take a look at this example on the right, we can see that all four forces are labeled. We have the applied force, which is moving to the right. We have friction force, which is the opposite of the applied. We have gravity force, which is pulling down. And then we have normal force going the opposite of gravity. So in a free body diagram, we have arrows, right? And length and direction is an important piece of that, right? And they are also labeled, okay? We know which arrow is which. So let's take a look at a couple examples. So let's take a look at the first example. Draw the free body force diagram for the car. Assume the car is moving. So since the car is moving, do we have balanced or unbalanced forces? It is unbalanced. Okay, so does that mean we're going to have all arrows the same size, or are they going to be different in size? Right, there will be something that will be different. Okay, so what's the force then that wins? If we remind ourselves, we have applied, gravity, friction, and normal. So it's unbalanced. So we're going to have at least one arrow that's different. What is the force that's going to win? In this case, the force that's going to win is the applied force, right? Because you're applying gas to the car. So that is your push on the car. All right. So the applied force then will be slightly longer than your other forces. All right. So let's go ahead and draw them in. All right. So we're going to go with applied. And which way is the car moving? It's moving to the left. Okay. So I'm going to draw an arrow. And I'm going to label that as my applied. All right, the next force we have in our list there is gravity. In which direction does gravity always go? Gravity always goes down. And so here's where I want to be careful. I do want to make sure that my arrow for gravity is shorter than my arrow for applied, because applied is the one we said would win. All right, the next force that we have written down there is friction. Where does friction go? Is friction opposite of applied or opposite of gravity? It is opposite of applied. So again, I'm going to do it, but I'm going to make sure that that arrow is smaller than the applied, because I need to show that the applied force is greater than the friction force. And our last one there is normal. What is normal the opposite of? It is the opposite of gravity. So again, I'm going to make sure that it is shorter than the applied, but I'm going to try to make it relatively equal to gravity, because the car is not being pulled through the pavement, nor is it floating in the air, so those two forces should be equal. So I'm going to try to keep them similar size. Let's take a look at another example. Draw the free body force diagram for the airplane. Again, assume the airplane is moving. So if it is moving, are we balanced or unbalanced? We are unbalanced, right? So if it's unbalanced, are all the arrows the same or is there something that's different? There's something that is different. So again, what are our different forces here? We have applied, we have friction, we have gravity, and we have normal force. So again, of those four, which is the one that's going to win? The applied force. All right, so let's go ahead and label. So we said the applied force is going to win. So which direction are we moving? We are moving to the right. So again, I'm going to make sure that I have my arrow and I'm going to label it as applied. My next force we have listed is friction. Where does friction go? Up, down, or on the left side? It'll be on the left side. And as I draw this, again, I want to make sure that it is smaller than my applied force because my applied force is the one that is winning. Next, we have our gravity force. And which direction does gravity always go? Gravity goes down. And where does normal always go? Normal is always opposite of gravity. And again, I'm making sure all these arrows are smaller than the applied, but that normal and gravity are similar to each other. Otherwise, we'd be going higher up or we would be falling down. Let's take a look at the last example. Draw the free body force diagram for the man pushing the refrigerator. Assume the fridge is not moving. So if it is not moving, are we balanced or unbalanced? We are balanced. And if we are balanced, are all the arrows the same or are they different? They are all the same. All right, so let's work on labeling this one. In which direction is the man pushing? He's pushing to the right, so we can say that our applied force is being pushed that way. What goes opposite of applied? Friction. And I'm trying to make these arrows look very similar to each other because we said that it is balanced, so our arrows should be the same. What forces are we missing? We're missing gravity. And gravity always goes which direction? Down. And the last force that we need is normal. So again, I tried to make all of my arrows very similar in size because we are saying that the forces are balanced because there is no movement. You will get a lot of practice on Schoology with this.